I'm a cybersecurity engineer at MITRE, as Alan mentioned, and among other things, I work on the Attack for Enterprise team, where I'm the cloud lead. So Attack, as you might have heard in the previous talk on track 1, is a globally accessible knowledge base where we discuss tactics and techniques that are used by adversaries and threat actors in the wild. So we're really focused on behaviors that these threat actors are actively engaging in order to help defenders and red teamers and cyber threat intelligence professionals have a common language that they can use to talk about them. What I like and resources and how we can exploit that. We often talk about the major cloud providers, Amazon Web Services, Google Cloud Platform, and Azure, as if they're all the same. But in reality, there are quite a few differences in how they handle identity and access management. And those differences can be important for how we think about defending those environments and escalating privileges in those environments. So good to consider how we think about permissions based on how these cloud providers think about permissions. I find this chart really useful. This was from an article by Tenable Cloud Security that compares the IAM systems in AWS and Azure and GCP. It's a little bit complicated looking, but actually it has a lot of really good detail. I think the important structures first are the permissions and resources section. So when we think about Azure and GCP, permissions and resources or roles and scope are sort of decoupled a little bit. So we think of role as this set of permissions that you have, and the scope as a sort of resource or group of resources. So these cloud providers have a strong hierarchy, and so it allows you to assign these roles up the hierarchy. So in Azure, you might have a role at the management group level, the subscription level, the resource group level, or the resource level. And you can see how as you go up that hierarchy closer to the management group level, you can have permissions over a lot more resources and a lot more data. In AWS, an IAM policy is a sort of collection of permissions and resources together. So you'll have an effect like allow or deny. You'll have an action, and you'll have a resource or a list of actions and resources. And these can be wildcards as well. So again, you can have potentially a lot of permission scope in one policy. In terms of human users, Azure uses what was formerly Azure AD is now Entra ID for user management. This is often federated from on-prem Active Directory or synced with on-prem Active Directory. So that's where these users come from. With Google Cloud, we have identities from Google Cloud Identities or Google Workspace. With AWS, we can have IAM users, although AWS recommends generally that you federate your identities from an external source and then allow those to assume roles. So instead of an IAM user with a permanent access key, we're thinking of a federated identity that has credentials and is assigned a temporary access token that allows them to perform certain actions. For service accounts in GCP, we have service accounts that can be assigned to resources, they can be assigned roles. In Azure AD, we have service principals or a subtype of service principals called managed identities that can also be, again, associated with applications, assigned roles. In AWS, you can pass roles onto resources like EC2 instances or Lambda functions, and those resources can then use those roles to access AWS resources. So some subtle differences, but all of them have user identities, all of them have service identities, and all of them have some ways to assign permissions to those identities. So same, but different, but still the same. So one other thing to consider that I think is really important is that on-prem, when we think of the final goal, if we're doing a red team engagement or a pen test, a lot of times we think of domain admin, right? We want as many privileges as possible. We want as much access. We want all the permissions. We want to just get everything we can, right? Climb to the very top of the ladder. But in the cloud, that isn't always necessary. So when you're escalating privileges in the cloud, it's important to think about what you actually need to accomplish, right? What's your goal? What are you looking for here? So for instance, if you're a threat actor and you're trying to crypto mine, then maybe you don't need more than permissions to spin up some virtual machines. If you're trying to access sensitive data, then maybe you just need read access to the right object storage or S3 buckets. If you're trying to mess with software supply chain a little bit, maybe you have write access to an S3 bucket and can modify a JavaScript file that some application is pulling from, right? You don't necessarily need all the permissions in order to demonstrate an impact. So that's something to keep in mind, right? You don't need global admin. You need to think about what you're trying to do. So now that we have that out of the way, we can think about how we actually elevate our permissions. And the first method is maybe don't. So there's a great report from Microsoft back in 2023 that talked about the state of permissions in the cloud. And they talk about how in the cloud, there's something like 40,000 permissions in these multi-cloud environments that you might have to keep track of. Over 50% of these might be high risk. And as a result, the principle of least privilege is really hard to apply. So what you're seeing in actual cloud environments is that there's 10 times more workload than human identities. So you're creating all these service accounts. They might not be monitored well. They might not have multi-factor authentication. Half of identities are super admins. They have tons of permissions. And yet less than 1% of permissions are actually being used. and over 60% of identities are inactive. This isn't because cloud administrators are lazy or incompetent. It's because the cloud is really, really hard. It's because permissions in the cloud are complicated. It's a big space, it's a new space, and it's hard to get everything right. We're seeing more tools to help defenders, tools that help them identify this identity hasn't been used in a while, this identity doesn't have multi-factor authentication, this identity has permissions it's not using. But even so, it's a lot to keep track of. So as pen testers or red teamers, we can take advantage of this because maybe we gain initial access and we have all the permissions we need. Again, thinking of those actions on objective, thinking of what our goal is, as opposed to accumulating as many permissions as possible. And this is something we see super common in threat reports and in the wild reporting. So for instance, a great report from Permiso Cloud Security on a threat actor called GUIville talked about how, given that cloud credentials are often grossly overprivileged, the threat actor often doesn't need to elevate privileges. And because I want to talk about attack, and we have to map everything back to attack, this is a classic case of everyone's favorite technique, valid accounts, cloud accounts. It's a big bucket. We dump a lot of behaviors into it because you're always leveraging valid accounts as a red teamer or as an adversary. But it's a really important one because all these actors have to do is get that initial access and use those valid accounts to accomplish what they need to do. So that's something to consider. Another report by Permiso on Scattered Spider, they choose initial victims who have the type of access necessary to carry out their mission. They have a goal, they pick their victims, and they have all the permissions they need. Again, a use of valid accounts, cloud accounts. But this isn't very fun to do if you're doing a pen test or a red teaming exercise. So maybe we should think of something that's a little bit more interesting in perhaps a slightly better defended environment. And so the second method I want to talk about is using credential access in order to escalate privileges. So credentials are everywhere if you know where to look. And I think the key point I want to emphasize here is that they're not just in the sort of cloud control plane. I think here is where you can really leverage this connection between cloud and other cloud environments. So a connection between infrastructure as a service and software as a service, or infrastructure as a service and on-prem, or maybe you have multiple infrastructure as a service providers, right? So you can look at all sorts of different spaces and not just stick in one. You can look at instance metadata, object storage, document storage, hosts and virtual machines, code repositories. There's all sorts of places. And we see this in the wild as well. So back to the Scattered Spider report, they've leveraged AWS Cloud Shell to scrape credentials available in Secrets Manager. And this is, of course, a case of credentials from password stores, cloud secrets management stores, because secrets managers are where you are supposed to keep passwords in the cloud, right? They're more secure. You're not supposed to just store them in plain text, but sometimes you might have access to something that you really shouldn't, right? You have a secrets manager, you're doing everything right, but then you give a user too much access and then they can read some of those secrets. So a very classic place to look for credentials. Another case, back to GUIville. This threat actor had read access to services, and they used that to review data in available S3 buckets and found credentials with administrator privileges in a Terraform file. I think this is an example of how we often consider security to be sort of securing the perimeter, right? And don't always think about what happens when a threat actor gains initial access, right? We know we shouldn't put config files with credentials and things that has full access to the world, but sometimes we give too many permissions inside as well. And so we can take advantage of that if we're pen testing by looking through, maybe in these S3 buckets, we can find unsecured credentials. We can comb through, we can see config files, we can see these Terraform files. Who knows what's there? Team TNT was a threat group that made quite a splash a few years ago. They did a lot of crypto mining with unsecured Docker and Kubernetes instances. And in their case, their malware would search for credential files on the host and also query metadata for cloud credentials. So what I find interesting here is this searching on the host in particular. We should think about credentials in files, right? We don't just think about the secrets manager in S3 buckets. Maybe there are interesting credentials on these virtual machines or even on-prem. Maybe some developers using this machine and they have a config file that lets them use the AWS command line interface. Maybe there are config files that let an application use AWS resources. It has tokens in them. So it's worth looking in a bunch of different places and not just sticking to one platform. And also querying metadata for cloud-specific credentials. We've all heard about the Cloud Instance Metadata API and how virtual machines can use that to get tokens and how you can use that to get tokens if you have access to the machine or find a server-side request forgery vulnerability. Next, another example of how it's really good to think about moving across platforms. This is a Microsoft report on a threat actor lapsus, and they looked everywhere. So they looked at SharePoint, Confluence, Jira, GitLab, GitHub, Teams, Slack, all looking for credentials. And again, we can look at these SaaS platforms and then maybe pull that back if we're thinking about escalating in AWS or Google Cloud or Azure. So lots of people have forgotten credentials and shared it in a Teams chat or a Slack group. Lots of people have committed credentials to internal GitHub repositories. Again, thinking, well, it's internal, right? It's not external, so nobody bad can access it. Or again, SharePoint, maybe giving instructions for how to access a service. So thinking about how all of these services interact with the cloud and with each other is really important. This one in particular is unsecured credentials, chat messages, and thinking about chat, again, beyond just Teams and Slack, but also about these collaboration platforms and ways in which users interact with each other more and less formally, right? Maybe you have policies against committing credentials, but again, that doesn't necessarily prevent someone from doing something wrong and trying to share something over a chat message. So all those ways of looking across these services and thinking about how they connect and what you can use these credentials you find for. The next part is on ladders. And I think this is really representative of how the cloud works in particular and what makes it unique. So sometimes you won't be able to perform an action with your compromised account right away, but maybe you can modify that account or another account, and in doing so, allow yourself to perform that action. So, for example, Scarlet Eel, this report by the company Sysdig, talked about a threat group that made some failed attempts to run EC2 instances, couldn't do it, and then decided to try to create access keys for admin users. And they found an admin user, admin Joe, who they were able to create an access key for. So this is account manipulation, additional cloud credentials. They added credentials to a cloud account. But importantly, this account was not their own, and this account had more permissions than they had. So by using this behavior, which is kind of more traditionally associated with persistence, they were able to escalate their privileges. They modified another account, and that account had more permissions than they had. Another report from Invictus Incident Response talking about an administrator access policy attached to a newly created account by using attached user policy in AWS, providing full access to AWS services. So this is a case of also account manipulation, in this case, additional cloud roles. So this threat actor manipulated their own account to give it more permissions. So again, maybe you can't do something, but you can modify a policy, you can attach a policy, you can kind of change the parameters around which these permissions are structured in order to give yourself additional access. And that's something that's worth looking through and combing through your permissions and really thinking about how they work. This can get even more complicated. So in the cloud, best practice is typically to avoid these permanent permissions or credentials in favor of more temporary ones. So I mentioned earlier, when we think about IAM users in AWS, instead of creating an IAM user with a long-term access key, they recommend using federated accounts, assuming roles, getting those temporary credentials back. Some cloud environments like Azure have implemented just-in-time access, which you could potentially enable on some services, which allows you to separate out this concept of permanent permissions from permissions you're eligible for. Maybe you have to manually approve them. Maybe you can automatically approve them. Maybe you need some justification, but this idea that you don't have all your permissions at all times. Account impersonation is something that you can do in Google Cloud with service accounts. So impersonate a particular service account. And these are mechanisms for, again, ensuring that users only have permissions they need at a given time. You're not just piling on everything to every user. So it's a new dimension to least privilege. But these mechanisms, it can be easy to misconfigure, right? So even though they're best practices, maybe you still give users too many ladders that allow them to move from the ground level to a more administrative or high privileged role. This is rare in the wild. We don't see a lot of examples of this. And I think this is because, as I mentioned earlier, oftentimes threat actors have everything they need right when they log in. So we don't see it very much, although it happens on occasion, but it's also really fun. It gets you to think about how permissions in the cloud are structured, and it gets you to think about what these permissions actually mean. So some examples of this. In AWS, I mentioned that you can pass roles onto instances that allow those instances to assume that role, use those permissions. Well, maybe you can't do something, but you have permissions to pass a certain role to an instance. And then you can take that token and you can actually perform these actions. And so what you're thinking about here is not what you can do, but what you can enable this instance to do. And you don't just have to think of EC2 here, right? There's all sorts of AWS services that you can pass roles to, like Lambda, CloudFormation, and data pipeline. Additionally, maybe you can just update a Lambda function to do something. It already has a role that you can find useful. So you can leverage these instances to do things for you. In Google Cloud, you can use the IAM service account user permission in order to do something very similar. Again, with compute, with Cloud Functions, with Cloud Scheduler. So thinking about how being able to pass these roles and attach roles to accounts can actually enable you to perform additional actions. In Google Cloud, you can use the IAM service account token creator permission, and that allows a user or service account to impersonate another service account. So you can use this in order to sign JSON web tokens and create OAuth tokens, and generally speaking, act as that service account. In Azure, you can use application administrator role to add credentials to an application, and then you can use those credentials in order to impersonate the application's identity. So there's a whole warning in the Azure documentation about how this can be a little dangerous if you don't do it properly. So if the application can perform an action that the user cannot perform, the user can steal the application's token and use that in order to do something. So again, it's really hard here because we're trying to think about not only just what permissions the user has right now, but what those permissions can enable them to do, what ladders they can climb with them. Can they make instances do something? Can they impersonate accounts? Can they modify their own account or other accounts? So it's a whole really complicated network that makes it a really fun space. So in some, for privilege escalation, maybe you don't need to do it at all. Maybe you have all you need. Maybe you can find a credential somewhere. Again, maybe not just in this one cloud platform, but using SaaS services or on-prem or virtual machines, looking through files there. And then again, maybe you can manipulate your account or leverage some of your sort of permissions ladders in order to gain more access. And this particular example is a Buse elevation control mechanism, temporary elevated cloud access. Again, thinking about all those temporary mechanisms for gaining permissions and new roles. So we're here, we made it. We're at the top, we're in the sky. What do we see? Kites. So kites have almost 3,000 years of history. They're very old. They've been around for a long time. We have written record of them for a long time. They were probably invented in China, and then from there spread throughout Asia. So to Korea, to Japan, to India, to Indonesia. Although some scholars think perhaps that they may have been independently invented in Malaysia, perhaps for fishing purposes, using kites made of natural materials like leaves, which is pretty cool. They didn't make it to Europe until quite later. We have a few records of some people, some Europeans writing about them, like Marco Polo wrote about man-lifting kites in China, but they didn't really become popular in Europe to maybe the 17th or 18th centuries. I think one point I want to make is that kites have had a lot of uses historically. So they were not just used as children's toys. So this is from the Encyclopedia Britannica. Over the millennia, kites have been used to ward off evil, deliver messages, represent the gods, raise banners, discover natural phenomena, propel craft, drop propaganda leaflets, catch fish, spy on enemies, send radio signals, measure the weather, photograph the earth, and lift passengers skyward. So kites have been used for a lot of different purposes. They've been used for military purposes for a long time, for reconnaissance, for signaling to troops, maybe giving orders, for dropping supplies. Kites have been used in a lot of early meteorological experiments. So Alexander Wilson measured the temperature at different altitudes. He was one of the first meteorologists to experiment with kites. Benjamin Franklin did his famous lightning rod experiment where he tied a key to a kite and flew it in a lightning storm, and then later used that information that he discovered about lightning and electricity to create the lightning rod. The Wright brothers used kites in their early experiments with aviation. In particular, they were trying to solve a major problem that had plagued designers of man-flying machines for a long time, which is simply how to control flying devices at altitude. And navigating in the air was a huge problem, and they developed a sort of wing warping mechanism where one wingtip goes up and another goes down, and experimenting on kites helped to later bring that experiment to their biplanes. Kites were even thought of as actually an alternative recovery system for Gemini space capsules in the 1950s. These were invented by Francis and Gertrude Rogallo. They sort of look like a hang glider kind of situation, and they actually sold them as toys to fund their research costs, although ultimately parachutes were used for the recovery system. One of my favorite examples of a kite invention was George Pocock's char-volant. He was a British inventor in the 1800s. He came up with a number of inventions related to kites. He did come up with a man-lifting kite at some point, which he tested first on his own daughter in a display of shocking confidence. And my favorite invention of his is the char-volant, which is a kite-pulled carriage. He talks about how it's one of the most pleasurable purposes to which kites may be applied, and perhaps the most useful of all. That didn't really come to pass. We don't travel around in kite-pulled buggies nowadays, but it's really charming. He wrote a whole treatise on his invention, which is in the public domain. You can read it. And he talks about these expeditions he would go on with his friends, traveling for miles, being pulled by these kites, how he would steer the carriage in different directions, going up to 20 miles an hour. He talked about how it would go so fast that at one point he passed the carriage of a duke, and that was a huge breach of etiquette, and they had to stop the carriage and let the duke pass again. And he talks about how you could even save money with this invention, because tolls at the time could be calculated based on the number of horses pulling your carriage. If you had no horses, you had no toll. So it's a really fascinating little read, and I find it a shame that we don't see more char-volants nowadays. Another early use of kites, World War II actually had a few of them. So there were kites used like barrage balloons, for instance, where they had these trail wires that could damage planes, so anti-aircraft devices. And the kites were perhaps a little cheaper, easier to maneuver than the balloons. They had the Gibson Girl box kite, which was used in sea rescue kits. It was bright yellow for visibility. And then there were Paul Garber's target kites. And I think these are really interesting because they're very early examples of steerable, maneuverable kites. So these were used for naval gunnery target practice during World War II. And you can see how this person has a harness that can be used to control the kite. So pulling it in loops, in dives, in figure eights. And there were 300,000 of these that were built. So they're actually used quite a lot. And yeah, I find the early example of just a steerable, maneuverable kite really interesting. And one last example is Samuel Perkins' man-lifting kite. So man-lifting kites have been basically a thing since ancient times. We've been writing about man-lifting kites. It seems to be a fascinating subject for inventors for a long time. Even Alexander Graham Bell, who was more famous for a different invention, got in on the action. He designed a tetrahedral 3D kite that had something like 280 pounds of lift. I mentioned George Pocock and his experience with man-lifting kites. So this one was developed for aerial reconnaissance during World War I for the US, but it was never actually used on the battlefield. I think in the early days, Germany and France may have used a few kites for scouting, but to be completely honest, these were big, easy targets. It was not really where you wanted to be, and airplanes just made them obsolete. But it's a really cool design. There was this train of kites, and they would lift this pilot off the ground, and there would be a team of maybe 10 people who would reel them in and out. It was not super safe. You were going like 200 feet in the air, and it was not stable. And at one point, in one experiment, the line snapped, and the pilot fell something like 70 feet and was only caught because the kites acted like a sort of parachute. So not really super safe, but a really fascinating example of history. More into modern applications of kites, one thing you might have heard of is kite fighting, especially if you read something like The Kite Runner. And this is popular in a lot of countries in Asia. It's popular in some countries in South America as well. It usually involves these small single-line kites. You'll see different shapes, often diamonds, sometimes rectangles. It really depends. They're usually flown by a team of 2 people, one to sort of maneuver the kite and one to let the line out. They're often flown with an abrasive line, so there will be a coating, and the goal here is to cut other kites. So cut the line, the kite is let loose, maybe you can capture your opponent's kite, and the last one flying wins. This isn't always the case. So this is a 6-sided traditional Japanese fighter kite. And in a lot of those, that's more about destabilizing your opponent. So knocking them out of the air without necessarily cutting the line. And if you see a kite battle in the US, it will usually be that sort of style. There will be, I think, one next week in Washington, D.C. at the Cherry Blossom Kite Festival. So it's a popular sport in a lot of different places and is a lot of fun to watch and takes a lot of skill. Modern sport kiting often takes the form, though, of 2- or 4-line kites that allow really easy maneuverability with one person. So these are controlled with handles or with wrist straps typically. And there are 2 main types. You'll have stunt kites. These are often triangle shaped, although they could be a number of different shapes, and they'll use rods. And their goal is more precision and artistry. So you're trying to have these a really responsive kite that will act like as soon as they'll act as soon as you kind of move your arm, or even in some cases your fingers, depending on how precise the kite is. And yeah, your main goal is just, it looks beautiful in the air. Power kites don't have rods. They're like a big parachute, and they're designed to pull you. So if you've ever seen someone kiteboarding or snow kiting or kite buggying, these will be using big power kite style kites, where they're just trying to generate all of this force that you can use to propel yourself. So examples of this, stunt kites, you'll see in the middle a picture of me flying a typical 2-line stunt kite with a tail. I have 2 lines here that you can see, and I've got 2 wrist straps. So one on my left hand and one on my right hand. And these kites can do simple tricks, loops and dives and figure eights. Out on the left and right side, you see revolutions, which are 4-line stunt kites. And these are almost more bow tie shaped. The revolutions will still have 2 handles, just 2 lines on each handle. And their goal is ultra precision. So you can do some more complex tricks. You can stop them mid-air. You can maybe even gently tap someone on the shoulder. So there's a lot you can do here, but they're a little bit more difficult to maneuver. And what's really cool is that you'll see large groups of flyers getting together and all flying revs at once, like you see on the left. So they'll stand in a big line and they'll all know how to move in these choreographed dances where all the lines are getting tangled, but the kites all stay perfectly in the air. It's really cool to watch, and again, takes a lot of skill. Power kites, a little bit different. Like I said, a big parachute. You can see them in the middle. They have cells that just fill with air and they will just pull you. If you get a larger one, like I'm flying on the right, instead of a wrist strap, you might have a handle to hold on to, just so you don't wreck your wrists with all the force. But I actually really like power kites because not only are they really fun, you get this attitude of jumping high in the air and wrestling the kite to the ground, but they're also great for beginners, I think, for 2 reasons. They're a little bit less responsive, so they're more forgiving. You can make bigger movements and more clumsy movements and not have to worry as much about them crashing. And even if they do crash, there's nothing to break. They've got no rods, so you don't need to have anyone worry about breaking anything. So I usually introduce beginners to a small power kite if they're flying for the first time. So you've chosen your kite, you know whether you're going for more precision and artistry or more power. Where do you fly? So the first option, my favorite, is the beach. That's where I grew up flying. Really windy, lots of open space. Obviously, not everyone has a beach. So if there's a big open field, that also works really well. You want as few trees as possible, and not just because trees are, well, your kite can get stuck in them, but also because they tend to block the wind. So if you've only got a small field with just enough space, you need a lot of wind in order to get that kite in the air. So the bigger, the better. Kite festivals are a fun place to fly, although they're not always a great place to fly 2-line kites. You can see in the picture on the right a photo I took at the Cherry Blossom Kite Festival in DC last year, and there is a ton of people and a ton of kites. If you try to fly a stunt kite there, you will crash into people, you will take other people's kites down, it will be a huge mess. So stick to single-line kites. You'll see a lot of fun big kites at kite festivals, like the ones on the left, big dragons, that's a trilobite at the top. So those are super fun. But yeah, stunt kites best where there are fewer people and more space. So, all right, you found an open spot, you have your kite. How do you actually fly it? I like to tell people that kite flying is a lot like riding a bike. And not necessarily because the action is similar, but because the mechanism is similar. So when you first learn to ride a bike, you don't really know what you're doing, right? It's confusing. You've got the pedals and you can't get your balance and nothing makes sense and it's super hard. But at some point it clicks and then you just know how to do it forever. You can go years without riding a bike and then you go back to it and it all just comes back. And kites are very much the same. It's a little bit confusing at first, but fundamentally anyone can do it. I've taught tons of people who didn't think they could, and they were able to fly it beautifully within half an hour. It just clicks. The basic concept is you pull left to go left, and you pull right to go right. But there's a couple of things that I tend to see beginners doing. Is the first, they overcorrect. So they'll pull left really hard, and then the kite will go crashing to the left. So they'll pull right really hard, and it'll go crashing to the right. So they'll just lose control and they'll get really stressed. Small movements. The kite knows what you did. So just trust it. You don't need to do these crazy big yanks. The second, keep your elbows in, right? Elbows to your sides. Pull back. The thing that I always see beginners do, and I warn them against this, but I think it's really quite an instinct, is they'll just go out, right? They'll see that they want to get their kite left, and they'll just pull all the way. If you pull back, it will move. If you pull out, it's not going to do anything. It's fine if you do it at first. I think it's a really strong instinct, but just remember, keep your elbows in. But fundamentally, it's not too hard. These kites are really durable. They're not going to break on you. It's worth giving it a try. It's a lot of fun. And once you get your first trick, it feels really, really cool. Our takeaway. So permissions in the cloud are really hard to get right. They're complicated, and they interact in really interesting ways to create this network of ladders and lateral movement opportunities and privilege escalation opportunities that is really fascinating from a red teaming and a pen testing perspective. Often you will be able to read something or do something that allows you to take one step up the ladder. Maybe finding credentials, maybe manipulating your account, maybe passing a role to an instance. It's just all about looking around, seeing what you can do, seeing what you can read, and just taking that in and thinking hard about how that can affect the environment. Also, kites are really cool, and you should fly them. If there's a local kite festival near you, you should attend it. Check it out, see what you can see. But that's all for me. If you have any questions, happy to answer.
Yeah, Casey, it's Alan here again. So there was just the one question. So it's an interesting one. What are the best ways to bootstrap getting credentials into a server system? So I guess the point being that if you have a server system that's going to be working on your systems that actually do all the work and have all the access, how do you get some service accounts onto them that doesn't then, can't be compromised at a later stage?
So there's different ways, and this kind of goes to the different cloud providers having different recommendations. Mm-hmm. So Azure will usually recommend using a managed identity that is associated with a resource. And with managed identities, Azure will handle the credentials for you generally. So kind of almost passing that responsibility onward and dealing with it as little as possible. And also where you can, limiting access, like a service account shouldn't necessarily be able to log in like an ordinary user account. They should be associated with an instance. They should authenticate, not using passwords, but with maybe certificates, just depending on how the cloud provider works. But they shouldn't be just something where you can just log in just normally. And if that has to be the case, then you really should have some sort of context-aware access where, you've got like a token associated with an instance, but then if that's used outside of that instance, then you get a big old flashing alert. So thinking about just tying it down, locking down the context as much as possible, so it's only associated with specific instances and specific resources. So maybe you don't manage the credentials, so maybe it's not traditional authentication methods, that kind of thing.
Okay, no, that's a good answer. Also, no more questions, but a lot of comments about the kites. I think everyone's getting very excited about it, and I think you have inspired some people to take it up. So yeah, well done. Thank you. Thank you. Very good talk. Thank you very much.